Um, so I'll just do a quick introduction about ThoughtWorks real quick. So if you don't know who we are, ThoughtWorks is a global technology consulting firm. We partner with enterprise clients to solve their most complex technical challenges. We were formed in 1993 in Chicago, and in the early 2000s, Martin Fowler, whom some of you may know, joined ThoughtWorks as our chief scientist. Martin was one of the first people to promote continuous integration as a best practice. ThoughtWorks also created one of the first continuous integration products called Cruise Control, which was open source. About 12 years ago, in 2006, we formed an organization called ThoughtWorks Studios to bring our developer tooling expertise to market. One of those products was then Cruise, which was a rewritten version of that continuous delivery product, which we subsequently rebranded as Go in 2010. And it was the first commercially available continuous delivery product. Jez Humble, who was the Go product manager at that point, then went off and wrote a book called Continuous Delivery, which some of you may have heard of. In 2014, we open sourced Go CD, making the product available to use at no cost. And since then, we have a rich community of contributors and plugins that have emerged to make Go CD a leading product in the space. So just a couple of housekeeping notes on the webinar. Chat is disabled during our webinar, but you can use the Q&A box to ask any questions. So feel free to put some questions in there, and we've reserved some time at the end of the webinar to answer any questions that you might have. So, and anything we can't answer by in the webinar itself, we'll send by email. So Ken, I'll go ahead and turn it over to you.
Great, thanks, Craig. And apologies, everyone, for the lack of video. I'm not feeling well, and nobody needs to see that. So today's talk is, want to successfully change DevOps, change everything. And it's a little bit, I think we put the hashtag kidding, not kidding on like the Twitter and so forth, because it's a little bit tongue-in-cheek, but not totally. It really is a multi-pronged type approach. There's more than one thing you have to change if you really want to adopt what we think of as DevOps, which I'll get into. So some of the changes in today's talk that we're going to go over. First off, I'm going to talk about the importance of a shared understanding of what words mean in your organization. And then talk about change to your organization itself, which is sometimes required, not always, but sometimes. The using modern architecture and technologies to enable a lot of this, and then using continuous delivery to safely deploy more often. So who am I? I'm from Seattle. I'm a technology evangelist at ThoughtWorks, where I've been here for about 10 years. I'm also a core organizer for an organization called DevOps Days, which, if anyone's not aware, that's where the term DevOps came from. You can follow me on Twitter at KMcGrage. The reason I bring up that particular, the who am I bullets, it's not, hey, look at me, but it's to say that I think I have a little bit of a unique outlook on some of these things because I work for a product vendor that comes from the technical side of continuous delivery and so forth, but I also spend a significant amount on the culture side of DevOps. And so I really see the importance of the marriage between those two. Okay, so the first part is titled Redefine Words for Your Organization. So what I mean by this isn't, that I'm going to give you a bunch of definitions, which I am, and that you should adopt them. It's to encourage you to have your own agreed upon definitions of different terms. So that if a team says we're doing unit testing, other people or everybody on the team, team member says that, everybody on the team agrees on what that means. And so, that's the importance there, is that we have a shared vocabulary where we can work things together. So first, what I'm going to do is what isn't DevOps. So it's not a tool set, it's not a platform, a product, what have you. As I mentioned, I worked for a product vendor. I think it's an important piece of it, but I don't think there's such thing as a DevOps tool. There are continuous delivery tools and monitoring tools and deployment tools and et cetera, and they're important, but they're not DevOps. It's also not a role, so I apologize. I'm sure at least some people on the webinar have a title that says something like DevOps engineer. I believe that's a little bit an anti-pattern, and I think hopefully that you'll see why when I come through this. I understand, Glassdoor said it's the second most hot job in the country right now. That is the reality of DevOps, is that that's what jobs are posted at and so forth. So again, don't mean anything against anyone using it, but I don't think I think it's an anti-pattern. On the same notion, it's also not a team. That'll go into quite a bit in a bit. So one thing that helps me when I'm thinking about it, and may help you as well, is to think of DevOps not as developers and operators, so nouns, but think of it as verbs. So DevOps is developing and operating, software or systems or whatever word you want in there. And so that's why a lot of folks, myself included, aren't big fans of things like terms DevSecOps or DevQAOps or DevBizOps or et cetera, because developing and operating a system should include security and compliance and user experience and all of those things. When you say developers and operators, it's exclusive. And I'm not one of those people, so that leaves me out. Now, the people who created the term DevOps kind of actively refuse to define it. They're like, if we do that, then it's going to get bucketed, and we really would rather people explore their own. But some people have tried to put some boundaries on it. One of the earliest came from John Willis, where he wrote a thing called CAMS. John Willis and Damon, forgetting Damon's last name, he's going to kill me. But CAMS stands for Culture, Automation, Measurement, and Sharing. And so, if you don't do the culture, and by culture I don't mean be nice to each other, we'll talk about org structure in a little bit, then the rest of it isn't really possible. And so today mostly we're going to talk about culture and automation, but the measurement and sharing is also really important. You have to know your baseline so you can know if you improved, et cetera. Sharing is just a big part of the culture itself. That's why things like DevOps days and so forth. Now, not long after this came out, Jez Humble, a former thought worker who wrote the continuous delivery book, added lean to it. We find that the most effective organizations are worried about things like product flow or project flow, not as much as iterative boxes and so forth. And so it became CALMS. Now, when I say DevOps, this is my definition, and there's a very detailed thing on my website. But again, the reason I share this with you is not to say this is the definition of DevOps and I said so you should adopt it, but so that for the rest of this talk, what I mean when I say DevOps. Okay, so to me, it's a culture where there's a team and it's people of all backgrounds and everything else deploy and operate a system. And so, system could be software, it could be the infrastructure, et cetera. But to me, it's a combined effort. And again, there's several different definitions out there. Adopt mine, adopt somebody else's, but you should have one that you agree inside your organization. This is what we mean when we say DevOps. Okay, so now it's quite possible that enabling a DevOps culture actually means changing the organizational model. And some of this we started to try to do with Agile, 19 years ago now, and some of it we didn't. So what I mean by that is we take a traditional model and we have our development teams. And in traditional Agile, we had a definition of done, which was we gave software to the customer. Only most of the time, that was actually a customer proxy. So a product owner or somebody like that. It wasn't really the customer. So then what we saw is, development teams would then hand it to a testing team, and they hand it to an operations team who'd never even seen the stuff before. And of course, there's walls in between. And some of these are actual firewalls, and some of them are just communication structures, and some of them are geography, et cetera. But there's really not a lot of communication here. So there's a number of issues with this, but from a DevOps perspective, what we want to look at is a thing called Conway's Law, which actually came out about 50 years ago. It's a paper written by Melvin Conway in 1967. And part of the paper is this statement right here, which basically is saying that if your organizational structure is development over here, and then a QA department, and then an operations department, and a security and compliance, and whatever it happens to be, then that's what the architecture of your system is going to be. Same with functionally. So if all of your billing and accounts receivable and what have you is in its own division, but the people that are doing inventory are in a completely different division, then you're going to end up with a architecture that mirrors that. And that might be okay, but it's something you need to be aware of. I don't think it is okay when it comes to a role perspective, but it tends to be true. So then if we go back to our traditional model, okay, so what do we do about that? So one of the things that we see do a lot, and you may not even notice this little slide change here, but renaming operations team to DevOps team does not count. Okay, so it's still walls. So unfortunately, a lot of folks are doing this. They're saying, okay, we're going to add change management tools like Puppet and Chef and what have you to what the systems ops people do, and now they're a DevOps team. But they're still getting handed the actual thing, the software project or what have you. They're still getting handed over to all. So yeah, their job responsibilities have changed, but the communication structures haven't gotten any better. By the same token, taking and forming another team, calling it a DevOps team that provides some of the automation. So a lot of times you'll see a DevOps team will create things like the continuous delivery pipelines. And so, okay, development teams, here's your CD pipeline. We've defined it for you. You do that, and it will take care of getting the software to all the other teams that need it. And so, that solves the automation. But again, it didn't solve the culture. It didn't solve the C in CAMs or COMs. So, again, we think this is an anti-pattern. What we'd rather see is these organized into product teams. There's a lot of things out there that have been written on products over projects. So projects typically have a start date and an end date and a fixed budget and a fixed scope or what have you. And so people don't own them. In a product team, actually the most probably famous quote from this is Werner Vogel's that said, you build it, you run it. And people quote this a lot, but they don't necessarily know all the context of why Werner said it. And I understand this is a lot of text on a slide, and so not asking you to read the whole thing, but it was actually out of a much longer interview. And what he said is, towards the bottom there, is this brings developers into contact with the day-to-day operation of their software. Also brings them into day-to-day contact with the customer. This is incredibly important because that feedback loop of did this product do what it was supposed to do? Not just did it pass its test, not just is the math right or is the service up, or what have you, but are we selling more books? Amazon sells a few other things besides books now, but that's really the point, is it really want to make sure that the teams know what's going on with the software so they can react quickly. That's what continuous delivery and a DevOps culture bring to you. Okay, so one of the more common hurdles also is the architecture of our systems. One of the things that we hear a lot, matter of fact, Jez does a talk on it, an entire talk that says, well, that's great, but it can't work at my organization because what have you. There's a famous story with Hewlett Packard, where they got it working on printer firmware. Now, it's embedded systems basically. I mean, it's not, but it's firmware, and they're like, how do you do continuous delivery on that? They had to re-architect it. And again, there's a whole book on that actually, but it can work, but it might mean changing your software, frankly. And so then you have to decide, is this the right thing to do? Does this match my business goals? Please don't re-architect it for the sake of re-architecting. So the most, common thing that we see a lot is large monoliths. And so folks are probably familiar with this, but I want to go through what we're thinking here anyway. So, let's say that we have a large travel agency online, and we have our monolith and all the functionalities in one process. And for whatever reason, we need to be able to scale hotels faster than anything else. There's new brands opening up all the time. There's new specials. People are traveling more, et cetera, what have you. In order to do that, in order to scale that hotel's capability, we have to scale the entire monolith. And by the way, this is only a semi-fictional story. And so what ends up happening is not only from a scale perspective, not only from we have to buy machines or buy space on a cloud or what have you that we don't really need because we have to scale one part of it, but also from a DevOps and continuous delivery perspective. I can't react quickly because in order to deploy a change to my hotel service, I have to make sure that everything is up to date with the car rental service and the flight service and the what have you. And so, the monoliths aren't always bad. There's a blog on gocd.org about a new product we started, tried to do services to start with, and turned out monolith was right. It's not that they're always bad, but you need to be aware of the challenges. So that's where we come into smaller pieces, things like a microservice architecture. Now, it's really easy to dismiss microservices as, oh, no, here goes Ken with another buzzword. But again, remember I said it's important that we have agreed upon definitions. So for us, in order for something to truly be called a microservice at ThoughtWorks, it has to truly be an independently deployable piece of code or piece of software. And so if there's two services that you have to deploy together, not a microservice. If there's two services that share a data backend, a database or what have you, not a microservice. Okay, it's truly independently deployable. Might still be a good service and so forth, but it's not a microservice. So with a true microservice, we take each element of functionality and it's in a separate service. So I could say like hotels is a service. In truth, hotels is probably several services. You know, one for booking, one for show me available, one for dates or what have you. But when I want to scale hotels, I can scale hotels. And so if I need far more of those than of car rentals or what have you, it gives me the ability to scale that. It also gives me the ability to react to change at that level, which again, from DevOps and CD is really the point. So if I need to make an update to hotels, if we add a new brand or what have you, then I don't have to wait for car rentals to work. I have well-versioned APIs. We're not going to break anything. We're going to have contract testing and a bunch of other things. I'll give you some homework in a second so you can learn all those buzzwords. But the idea is that it's independently deployable. So what does that do for us? We go back to our product teams, and it allows product teams to own a certain part of our offering. And by own, I mean from like idea to cha-ching is the way John Willis puts it. But hey, what feature should we try? Okay, here's where we do it. How are we going to measure it? Are we going to do A/B testing? You know, et cetera. Okay, now it's in service, and now it's it went down at 3 a.m. and someone's going to have to fix it. You know, et cetera. The product team owns it. And they're going to own more than one. And so, you know, it's not that the rental car service is only going to do rental cars forever. Once the core thing's done, they might pick up more, et cetera. But it is an ongoing ownership. So I mentioned a little bit of homework because I went through a lot. But building microservices by former ThoughtWorker Sam Newman is really good for understanding like the coupling and how to test them and those sorts of things. Also, there's a book that's related called Building Evolutionary Architectures, also by a few ThoughtWorkers and one former, that talks about the need to architect in a way that you can react to change. So it doesn't say build microservices, but it's to build them in such a way that 2 years from now you'll be able to evolve along with the things. So just some homework for you, if you will. Okay, so that's great. So we have we have our cute little microservices. They're all cool. Sam Newman would agree they're a microservice, but we still have to deploy somewhere. So this is where I like to talk a lot about platforms, and one of the ways I explain this a lot is using this slide of car as a service. So I don't know if everybody's from North America or places that have car leases, but we do here where you can lease a car. Basically, the idea is if you own a car, it's yours. It's on premises. Excuse me. I need to change that slide. So, I mean, the payment for the car and depreciation and renewables, everything is your problem. It's yours. With infrastructure as a service, that's kind of close to car leasing is the way I like to think about it. And so, yeah, you get the big parts are taken care of, but it's still you're doing all of the renewables, all of the service packs and security updates, and all of that kind of stuff is still up to you, and you have to return it in a sellable state, so you can't change the infrastructure around, et cetera. A car hire or a rental car, basically you pay the consumables. I pay the fuel and road tolls and driver, and I should have some insurance probably if I wreck it. But everything else, changing the tires and the depreciation and finance costs and all of that stuff is covered by the rental agency. And then a taxi or that kind of thing is like software as a service. I'm just going to pay someone else to do it. And the whole thing's their problem. Just get me from point A to point B. If it breaks down, I'm going to get out and get in a different one. So that's a SaaS thing. What I like to focus on, and something I'm really, really hot on for DevOps and CD, is the platform as a service model. And so an example I use for this one specifically a lot is an organization called cloud.gov. So cloud.gov is an official service of the United States government. So if you're in the US government or you work for the government and you're trying to deploy an application to the cloud, there are a whole bunch of security controls and other controls that you have to abide by. So 325 of them at the time that the blog this came from was published. It's probably gone up or down since then. What this does is it provides a platform for deploying your application. So depending on your app code, like if you follow their, these are our really well-supported things, they own a different amount of those for you. So at the worst case, they handle 269 of those required security controls. So you're just done. You don't have to worry about proper DNS and patching of the operating system and all of those things. They're handled by the platform team. 41 of them are shared, so your application is going to touch certain parts, and 15 of them are solely your responsibility. So you've gone from 325 to 15. And I use cloud.gov as an example, but this is kind of the case of, or the point of platform as a service elsewhere. You know, if you went with Google or Amazon or Azure or what have you, and all of their different offerings and so forth, the whole point of that is to shift some of that off so that other people are managing it. And that's what enables you. So one of the things that enables you to deploy quickly. Now, don't panic if you're one of those traditional ops people. You're like, no, we have a data center and I'm going to rack and stack and I'm going to get to you. I'm not saying you're out of a job. Definitely not. I'm saying the platform model is a good model. Part of the reason for that is this quote. So, the cloud is still a computer, right? There still are operating system patches. There still are power supplies and hard drives and all of those things. And so whether it be public or private cloud, ThoughtWorks, we have both. It's still, somebody's got to run it. So let's not forget that. The whole term no ops and things like that, please, no. They're still ops. So we go back to our product teams. It's funny, I've given this talk, or at least these couple slides in public, or in person, I should say, a few times, and you see the looks on folks' face when they're like, I don't want to be on a product team. My background is traditional ops, and I'm good to learn automation. I'm good to learn the Kubernetes or, whatever it is. But, I don't want to be on a product team. So I'm saying that your organization, for the things that are products, should be product teams, but let's not be mistaken. Again, the cloud is just somebody's computers. So there are still all those other roles that we need. So like there might be a platform team who their job is to run a public or private cloud platform. So they're going to run OpenShift or Cloud Foundry or manage your Google accounts or, what have you, and hopefully have some type of agreement with the product teams that says, this is the platform, this is what we support. If you deploy the things we support, then we'll take care of it from here down, and you take care of it from here on up. The product teams are still able to choose, technically a microservice, if it's independently deployable, could be in any language or background or what, and they say you can still do your thing, but this is the platform we're going to provide. And also, I've breezed by it a couple times, but there's some other fairly important things in our organization. Compliance is still important. There are privacy laws, much stricter in Europe than in the US, but if the global economy these days, it's everybody. Security is kind of important. And so, these folks still exist. So I'm not saying that every team has their own security expert necessarily, because there's probably not full-time work. And so some of these other teams still exist, but there's no throw it over the wall. They're, mentors or consultants, or they might embed on a team, or what's it called, matrix organization. There's a ton more about this, but the idea is that we're not just saying that, okay, everybody's on a product team now and everybody else is out of a job, we're just going to pay Amazon, which might be the case for the platform team, but that's certainly not the point. Okay, so if we've figured out our language, we've talked about our organizational structure, et cetera. We want to deploy more often. So use continuous delivery. So for this one, I'm going to go to the definition by Jez Humble, who co-authored the book by the same title. And this one I'm just going to read the whole thing. Continuous delivery is the ability to get changes of all types, including new features, configuration changes, bug fixes, and experiments into production or into the hands of users safely and quickly in a sustainable way. So the reason I read that whole thing to you is a couple things. So first off, it includes new features, bug fixes, everything. And so if you're going to change the version of OpenSSL you have on your system, that goes through continuous delivery. But then the other one that people tend to bypass a lot is this big word down here, which is safely. Okay, so the whole point of continuous delivery is to get the things out there safely. It's not to skip important pieces. It's to get it out there safely. So the homework here is the book by the same title called Continuous Delivery. Again, two former ThoughtWorkers. But it's kind of the gold standard for what is a pipeline and et cetera, et cetera, et cetera. So one way I look at this a lot is I say that continuous delivery is what you do as part of a DevOps culture. So when I say you can't do DevOps, et cetera, that's what I mean, is you don't do DevOps. DevOps is the culture of the teams working together, developing and operating software. Continuous delivery is one of the things you do. That's the automation part, or this is the automation part of comms. Now, that said, you can't skip ahead. And so before you can do continuous delivery, because again, safely, you really want to make sure that you're doing real continuous integration. If you get the ThoughtWorks radar from earlier this year, I believe, we actually put a pattern in there called, or anti-pattern, called CI theater. And basically what this is people that are doing things that we would say are not continuous integration, but calling it continuous integration. So they weren't really doing all the tests, et cetera. And then it goes in quite a bit of detail. But they're saying, oh yeah, we're doing CI. So one of the things we did inside the product division of ThoughtWorks is we did a survey, and we said, are you doing continuous integration? And if people said yes, it presented them with a number of questions. And okay, well, are you doing this or that or the other thing? And then it was like, well, are they really doing CI, or are they just saying they're doing CI, or what have you? This is the one that scared me. So we hope that you'll download GoCD and try it out, and we're doing a trial of some of our commercial add-ons like analytics and so forth. We think it's a great tool, but downloading GoCD or Jenkins or Bamboo or TeamCity or Circle or whatever is not the same as practicing it. Okay, so it's again, tools are important, but they don't solve the thing. And I was shocked to hear that only 10% of the folks, based on their answers to these questions, differentiated that. So it is important. These are practices, and some of them are not easy. They're well known, but some of them are work. So a litmus test that Jez Humble and Martin Fowler, our chief scientist, put out a few years ago, say, are you practicing CI? So the first one there is every developer commits at least daily to a shared mainline. Call that trunk, call that master, call that whatever you want to for your version control system. But everybody is committing to that at least every day. Probably a lot more often than that, but that's the at least every day. And notice this is not long-lived feature branches and so forth. This is the mainline. Every commit triggers an automated build and test, and this is every test. And so this is where the continuous delivery server comes in, and it's running all these. And then the last one there, if build and test fails, it's repaired within 10 minutes. It's very rare that I see people actually doing both 1 and 3. And so, 10 minutes might be a soft number, but the point is that there's nothing wrong with breaking the build. Okay, so it used to be, I'm a little older than probably most people on the call, we would build things that would take 6 hours to build. That's one thing, but now we're not in that world anymore, especially if we're doing things like the microservice architecture. So it's okay that you use the CD server for what its purpose is. And builds go bad from time to time. What's not okay is leaving them red. We often will see things where people will say, oh, that test is always red because that service is flaky, or what have you. And then they come to find out days or weeks later that, oh, there was something else failing and we just assumed it was the thing we knew about, et cetera. I'd rather you quarantine them, take them out, get rid of flaky tests, a lot of people don't like it when I say this, but I'd say no test is better than a flaky test. So if your CD pipeline, if it does go red, fix it. This graphic is commonly used to describe what is a continuous delivery pipeline. Okay, so we're doing continuous integration. So what is a pipeline? And what this shows is the flow that goes through that says, okay, delivery team checks some things in. And again, things could be source code for the product. It could be a configuration change based on some CM tool or what have you. But it runs some tests. If they fail, gives them the feedback, and they fix it and move on, et cetera. And so, these are just some examples, but possibility of going through things. Now, there's two terms that are commonly interchanged, but should not be. So continuous delivery is the ability to deliver the software at any time. So my software is always in a state that somebody could walk up, click a button, and it goes to production. I actually give a talk that call it "It's not continuous delivery if you can't deploy right now." And so it's always in that state. Continuous deployment doesn't have the click. It goes automatically. If all the tests pass, it shows up in production. I strongly believe that the amount of testing, what you're doing between the two, is exactly the same. You certainly wouldn't want to go to continuous deployment until you have mature continuous delivery, so you're running all the tests, okay? But I don't think there's less testing in continuous delivery. It's just that your business model has made the determination that you don't want to deploy every change. So I'll use GoCD as an example. GoCD is on-premises open source software. So you download it, whether it be direct download or package managers, et cetera, but you're putting it onto systems you control. And again, I mean, it could be a Windows installer, it could be Kubernetes, but the point is you control it. If we gave you a new release 3 times a day, Kubernetes folks would be like, yeah, okay, cool. But the people putting it like on, Windows servers in a data center, not so much. And so we've chosen continuous delivery. We deploy roughly once a month. Continuous deployment you would use for a SaaS product. Okay, so let's go back to our teams and talk about their role in continuous delivery. So again, and insert your team here. Okay, so I said product, security, and compliance just to keep the slide relatively simple. But there are others that are gonna interact. And what is their role in the continuous delivery pipeline? So I strongly believe that the product teams should have a direct path to production. And so if the product team changes a thing and it runs all their tests and they either click the button or choose continuous deployment, it's in production. Now this rightfully scares the heck out of a lot of people because they're, they're not experts on this or that or, et cetera. And so that's not good. So some examples of things that worry people, and rightfully so. We don't want to deploy insecure software. None of us want to end up on the cover of the newspaper or the CNN.com, whatever, for the wrong reasons. We also don't want to deploy non-performant software. And so there's been study after study after study that says, if your website's slow, people are going to leave. And so we want to make sure our performance is safe. And if anyone's ever done performance tests every couple of months, you know that once something comes in, it's incredibly hard to find. So you want to run these as often as possible. We also don't want to deploy software that's out of compliance. And so, ThoughtWorks is a global company, so we deal with the European data laws like GDPR and, of course, other compliance laws and so forth. And we do not want to violate those. We don't want some team deploying something to production that's storing someone's personal data in a way that's not in compliance, and next thing we know, we get a massive fine. So, we have to worry about those things. And the one that I think people often leave out, we also don't want to deploy ineffective software. So let's go back to our travel company. If I'm deploying that hotel service and I change a feature and reservations go down, that's bad. So we want to check for that kind of thing too. I'm going to go a little further and pick on security. Sonatype did a survey. Sonatype runs Maven Central. So if you use Maven, you type Maven build, it downloads the internet and does a bunch of things. They found on an average 23% of the packages being used off the public Maven repository had known critical or severe security vulnerabilities. And what's worse, these have been since fixed. And so there are lots of tools out there for checking these things. So, if it's Ruby, there's Brakeman. There's all kinds of tools that make sure that the stuff you're being used is there. Those should be in your continuous delivery pipeline. which brings us to the purpose of a continuous delivery pipeline. Okay, it has one purpose. The purpose of a CD pipeline is not to get software to production. It's to stop software from getting to production. It's to kill a release candidate. So every time you commit code, it starts to run a bunch of tests. And if those tests all pass, you have the confidence to click the button. The purpose of a continuous delivery pipeline is to prove it's not good enough, that you shouldn't click the button. So we'll go back to our pipeline in those roles. What that means is we want the capability to run other types of tests all the time. So, one of the things that I say all the time is that this is the difference between a continuous delivery tool and a continuous integration tool. So, a continuous integration tool can easily run, different kinds of functional tests like, Chrome and Firefox and what have you in parallel. But it's not so easy to have a completely separate team, because they're the ones that understand security or compliance or what have you, set up a pipeline that the entire pipeline is going to run in parallel with yours. That's going to run like OWASP tests or server spec or inspec or those kinds of things. So again, we're not going to slow down the product teams. I really think it's important that they have a direct path to production. What we are going to do is every time, so I brought up Maven, so let's pick on Java a little bit. So if we run a jar file and it passes all its unit tests, our other pipelines grab that jar file and start running other types of tests on it while the functional tests and the deploy staging are running. So we're not slowing down the pipeline. We're not introducing a dependency. We're not saying that, well, you're dependency, probably, but not inline dependency. So we're not saying you can't test a staging deployment until the security tests are done. We could if we wanted to, but we're not in this case. We're not saying the functional tests aren't going to run until the compliance tests are done. Okay, so we're not slowing down the pipeline, but we are running these every single time to make sure that we have the smallest amount of change to fix when something goes wrong. And I very purposely say when, not if. I mean, things are going to fail, but that's okay because that's the pipeline's job. So again, I picked on security and compliance here, but performance, the thing for your organization, whatever it happens to be, this is where, vendor hat on, admittedly, but this is where a CD tool is different than a CI tool. It allows us to do these things across multiple teams, multiple pipelines, multiple code bases, and still do a diamond dependency or fan in, fan out and make sure everything works. Okay, so the bad news is there is no silver bullet. I've gone through a few of the higher level things. It's not easy, but the good news is these are solved problems. Okay, so when I say it's easy, what I mean by that is there's effort involved. You might have to re-architect. You might not. You might have to get better at testing. You might have to look at your branching strategies. You might have to look at those things. But the good news is these are solved problems. And so, here's 4 more things. I think that brings us to 7 books total. I'm not expecting you to read all 7. But there's things out there that can help you with that. ThoughtWorks, we're happy to help you with it. I think Craig's going to tell you a little bit about trial programs we have for GoCD and so forth. But there is lots of help out there, so don't hesitate to find it. So, summary. I believe the definition of words is important. So, again, not that you'd agree with me, that you agree with each other. You might have to change your organization to enable DevOps. If we're really talking about a DevOps culture, if we're not only talking about automation, if we really want, the whole part of developing and operating to be together, it might be an org change. Modern architectures and technologies will help this a lot. So this is where things like microservices is why they became a big deal. If you go back in the timeline, you'll notice that continuous delivery and DevOps and microservices all came down separate but related paths at about the same time, about 10 years ago, because they all kind of carry off of each other. And the idea, again, of CD is to safely deploy more often. I'm not a big fan of the thing of, my pipeline, I can get to production in 12 minutes. Unless it's truly a small microservice, you probably didn't run all the tests if you really got to production in 12 minutes. So, the point of the CD is to deploy it safely more often. With that, so I thank you. There's some links here to ThoughtWorks.com products, talks about the offerings we have around some of our products, and GoCD.org if you want to check that out. I see that there's a couple questions. I guess also, Craig, if you wanted to say something before I get to the questions here.
Yep, sure. Thank you, Ken, very much. So we're going to get to the questions right now. I'm also going to launch a poll. So if you get a moment, if you could just go ahead and fill this out, that would be really great. It would give us some insights into how you, what you thought of today's presentation. So Ken, I'll go ahead and read the first question, Ken. It says, if DevOps isn't a tool or a role, does that mean it expands beyond development and operations teams?
It certainly does. Yeah. As a matter of fact, let me go back here 1 second. Sorry. Yeah, that's kind of what I meant by this slide. And so I don't think of it as developers and operators. I think it is developing and operating. And so the point was that, yeah, it's not just people that are writing source code or Java. It's not just the people that are managing Linux or Windows. It is the entire scope of developing and operating software. And so that absolutely needs to include things like security and compliance, et cetera. I don't think there's a DevOps team because, again, I think it's a cooperation between those things, but it does definitely need to expand beyond those.
All right. So the other question, it might be a typo here. The question I will read says, "Do not understand CD versus CD," but I'm going to just guess that it's
nope,
CD.
That's not a typo.
Okay. Very good. Continuous delivery versus. All right, go ahead, Ken.
Yeah, so really the difference boils down to, I went pretty long-winded. Continuous deployment is fully automated. If I make a change and it passes all the tests, it ends up in production without any other interaction from people. If I want to have a manual stage in there at some point that says that needs an approval, whether that be a compliance team or a product owner, whatever it happens to be, then they click something. Now that's continuous delivery. So fully automated versus not.
All right, so here's another question. What about dev teams that are focused and have mandated features that need to be done complete quickly, and because of this don't have the time, patience to learn a lot of DevOps tooling that is required to function as a product team? Would you, in this case, just try and hire people that have required skills and implement them?
So I'm going to take this in two parts, actually. So that is one of the big advantages to the idea of a platform first, is that I certainly don't expect a person that's a subject matter expert in credit card processing to then have to go learn everything there is to know about GoCD. And so that's where I like, or Amazon or Azure or what have you. That's what I like about the platform model, is what we can do is we can say, okay, so we are going to provide you with the tooling. So we've chosen, and I'm just pulling numbers or things out of the air. We've chosen Amazon and we've chosen GoCD because, hey, I work for them. And we're going to make the platform available to you. Going to have to teach you a little bit about what pipelines are because, again, you're going to own it, so you need to know it. Yeah, that part is important. You might have to hire somebody for that knowledge, but it is important to know what a pipeline is. We're going to allow you to define your pipeline, like in your own source code, for example. So that you can do that. We'll create the tool. We'll manage it. We'll manage the infrastructure. We'll so forth. We'll manage the Amazon accounts or what have you. But then we'll say, okay, these are the things that our platform supports. If you will deploy, Docker containers, because I don't think I've said Docker, and you can't have a presentation without that. If we're going to deploy Docker containers on Kubernetes, so you must have a Docker container and it must have these things. What you put in it is up to you. If you want to use Ruby, go ahead. If you want to use Java, go ahead. Doesn't matter. So you focus on your features, but this is the platform we can give you. That's kind of the advantage of it. When you take a dev team and you say, no, you now have to learn configuration management tools like Chef and Puppet and what have you, and you have to learn everything about Amazon and Google, that is probably not a good thing to do. Now, one thing, just do you hire people or maybe you hire people, maybe you hire a service. I mean, this is where, platform as a service from a commercial perspective, Amazon or Google or Azure or what have you, they have a lot of this expertise. And so, that might be the way to go for that. I would also say this is where SRE model, Google's SRE model, which I didn't go into a little bit, but they wrote a whole book on it. At Google, they actually have a separate team that will make sure your system stays up or what have you once you've proved it's good enough. So the product team has to own it all the way through and has to get it stable in production and can't go above a certain error rate and da-da-da-da-da. And once they've proven, yes, this is good enough, then the SRE team will take over some of the day-to-day running. not new features and so forth, but they have to earn that right to get it over to that platform team.
All right, so here's another question. How do you change the culture within dev teams such that they understand the importance of product teams and DevOps culture?
Boy, that's a really hard, it is a really hard question. I'm actually going to answer it partially with the name of a book. And again, sorry to add another one of these to you. But there's a book called Driving Change. You know what? I see that your name's on the question. We'll email you a link to it or what have you. It's about the human part of driving change. Unfortunately, or I guess fortunately that we know it, people don't react well, or at least the way you would want them to, from a pure numbers perspective. Like you can't say, okay, I got the state of DevOps report, and according to this, people practicing these things are 22% more likely to blah, 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 blah. You know, in the end of the day, people think that's important, but they don't really care. You have to make it more personal and how's it to do. A lot of times for dev teams, if they start to learn how much more time they'll be able to spend on new development versus maintenance stuff, because everything's smaller incremental changes, things like that. So there's all kinds of culture change stuff in there, but it's really more about socializing the benefits of it, and making sure, by the way, that the benefits are there. So, you know, don't do it just to do it. Do it because there's this problem you're trying to solve.
All right. And if your people are in the same location, would you prefer mixing these people in the same room as a product team? If all your people. So
yeah.
Mingling teams.
Okay. So at the risk of making me unpopular with my boss, I'm not a big fan of like open office concepts. I do think it's important that people have the ability to focus, and that they're not interrupted constantly. And so, like, for instance, if there's a separate team that's running compliance and security pipelines, for example, and they're all in the same location and they're interrupting constantly, that can actually be bad. And so I don't know that physical location, but I'd want to have a model where the product team does have focus time. They have time to say, we're going to mob on this problem. You know, we can't figure out how to work on this data set. We're going to mob on this without anybody walking up and saying, hey, did you hear GDPR version 2 is coming out in 2 years? You know, something that's not vital. I'm a remote worker, and that doesn't necessarily help it. So I don't know that it's all about being in the same location. There's pluses and minuses. I'm not sure I really can give a good answer to that.
All right. Is there a case where CD is a bad idea? Continuous delivery is a bad idea?
I don't think there's a case where continuous delivery is a bad idea, and I stress delivery over deployment, because I mean all continuous delivery means that your software is deployable at any one time, and so I can be writing software for satellite. I'm not going to deploy it all the time, but there's not a bad idea to keep things deliverable, because heck, the project could get canceled. There could be a million reasons why oh well, we're not going to be able to finish this, but oh well, we have something that's deployable and usable, so let's go ahead and release it. Continuous deployment, I think, is a bad idea on a lot of different kinds of projects. Like, there's certain apps I have on my portable devices that I get updates every 3 days, at least every day, if not every couple days. That's annoying. I don't really need, as a user, I don't need an update every day or 2 days to fix a typo or what have you. And so that's why I say it's a business thing. So, the business should say, when we need to deliver. So we have, let's say we have a big conference in October. We might say we want to have continuous delivery. So we could deploy tomorrow if we had a security problem or an emergency, but our plan is to deploy the day before that conference. So I think continuous delivery, in other words, is almost always a good idea. It might not be worth the effort to get there if it's not a system you're updating a lot, but it's probably a good idea to have your software always deployable.
All right. So this is another good lengthy question. How do you go about creating proper CI, continuous integration? We currently build regularly and run some tests, but it's not to the same master branch. It's more like Git flow. How can I work on moving the team towards proper I'm going to go ahead and call it continuous delivery, taking into account we also version our database and all the other shenanigans that complicate the process.
Well, again, it's a culture change. So one of the things is like if you're doing like branches and merge, there's actually a couple really good articles on martinfowler.com. one about feature branches, his CI stuff. He was one of the people, if not the person, that defined continuous integration, 2000, 2001, something like that. It's understanding the benefit to them. The benefit to them is that when they commit the code and it fails, then they can go right away. I don't want to switch over to a live web browser just based on time, but like if you commit code, if you do a pull request to go CD, when the first stage kicks off, it runs literally thousands of tests. And we know within minutes if any of those tests failed. And so it's a safety net. And because it's not like there's not 9 branches running or what have you, I can run that. We have a feature in GoCD called Elastic Agents. We can spin up 20 build machines, run thousands of tests, get feedback in a few minutes. And so it's much safer. And then if people have to fix problems, when people have to fix problems, it's a much smaller amount of code that they have to go through to fix them. And so it's really a matter of being able to react faster. And then it's just, how much time you want to spend on tech debt versus new features and so forth. There's lots of stuff to it. But I'd recommend, martinfowler.com and trunkbaseddevelopment.com as further reading on that.
All right, I think that's the last of the questions, Ken. So with that, we'll go ahead and thank you all for joining us today. We'll do this webinar again for folks in Europe and Asia Pacific. So if you're interested in attending this again or sending some of your colleagues, just keep your eyes peeled and we'll let you know. If you're interested in learning more about Go, please visit gocd.org. It's free to download and use. We also have enterprise packages for support and some add-ons as well if that's of interest to you. Thank you all very much.